My name is Sebastian Pesz. I'm from Axivo. I'm the new business manager. And today I would like to focus to key digital tool to help maximize your performance on your production. In this case, I would like to show you our customer cases where we implement the OE performance monitoring and microstops monitoring. I try to tell you a little bit more about this tool, but before we start description, I would like to tell you about the challenges which give us our customer. Of course, the most important for us and for customer, of course, is there's a connection with the machine. So customer want to connect with machine, and it's not easy for us because on every production we have different age of the machine. Real-time data is very important because we take the data from the machine and we can check the line performance on our production. The next challenge was manual data collection, which is time-consuming and created the problems, the errors prone. So in this case, we would like to delete this problem. The next one is the no clear data to identify the root causes of losses. It's difficult to check where we lost our efficiency if we have data after few hours in the next days. So this is the challenge. The next one is difficult in tracking and improving OE over time. And the last but not the least is standardizing performance metrics across line and sites. This is the challenge which give us our customer, and now I try to explain how we solve it. First of all, we need to connect with the machine. Since 19 years, we have experience in different machine connections. So in our opinion, we know it very well how to do it. As you see, we have different kind of connection with the machine because, like I said, the age of the machine can be different. If the machine is very old, then we can add the additional sensor like I/O modules, like cameras and any other necessary thing. This is the example of our production, of customer production. For example, the blister machine is connected to our system by OPC UA. Check weighers, like for example, Metal Toledo, is connected by their own protocol. Serializer case speaker is connected by PLC, but it's not that easy because we have different producer of PLC with different industrial network, like Siemens Profinet, for example, Allen Bradley Ethernet IP, Beckhoff Ethercat. So in this case, we don't have easy way to connect with the machine, but like I said, we have 19-year experience, so it's not difficult for us, and we do it well. Our team have very high experience. The next thing is master data and connection with external system, mainly with ERP system, but not only, of course. We call very often, we need the one source of truth. That means the master data should be in one place. In this case, if we don't have connection with external system, of course, we create the data in our system. But if we have a interface, then we create the both side interface. I mean, customer change something in ERP system, and then we have a very fast update in OE system and in different way. Because the data should be always the same in every system in customer facility. As you see on the slide, it's possible to connect with every system existing in customer facility, and of course we're ready to implement the system, our system on server on premise or on cloud. These slides show how it's looking the operator panel. And this is the real slide from our system. We have here the most important data, like order, like start production in plant sequence. We have state of the machine, and we can give all this data to operator. Operator can call technician and know what he's producing right now, what is the order, and focus on customer KPIs. Now I try to explain a little bit more about the microstops and microstops monitoring algorithm. What exactly mean the microstops? The microstops is very short break on customer production, for example, under 1 minute, but the time depends of the customer. How is working microstops algorithm? We are connected with the line, but not only with the line, because then we don't have too much information. We are connected with every single machine on the line that give us the very big data and can show us can detect the bottleneck on the line. That means if you checked on the slide, then you see the red lines. That means the single machine on the line have microstops, and we have information for the line. Is this microstops have impact on the whole line or no? Then we can very fast react and check what's going on our line. Here we have more details, and if it's necessary, and always is necessary, we can focus on every line on every machine. Then we have, like I said, real-time data with microstops on our production. Every single step on the production, on customer production, is important. In this case, we can create together with our customers operator checklist for every single step on production with steps for every single station on the production. This checklist can be connected with orders, with items, and with the machines. That means the operators see only steps dedicated for his station. We don't want to show him all big description, instruction, just important steps for his station. For example, in this case, we can check how it's. We can create for the operator the changeover list with every single step. After the changeover operation, system generate, of course, the report, and customer can compare the real-time changeover to default one, for example. Operator give the feedback for the system, but operator have a feedback, but the system give the feedback for operator. So in this case, he knows very well what's happening on his line, and he can react very fast, react on any deviation in real time, what is very important for OE and for performance of the line. To make it as easy as it's possible, we together with customer create state for every machine connected to the station. This is the first step of one of the first step of implementation, because it can be difficult. Some customer can have a lot of states on different machine. We create, for example, that view for our customer and for operator. So in this case, he can choose only the state existing on the screen. He cannot change nothing. So it's easier for him to, and we don't want to lose his time. He need to focus on the production. KPIs definition and how we calculate the OE. Our system can standardize OE calculation, which help compare data for different factories in the same company, because different factories can calculate OE in different way. We can standardize process to calculate OE in every location. In this case, customer can very easy compare the data from different location and increase his OE. Because we have cases where when our customers show totally different OE on the same line but in different factories, When we focus on this numbers, then we have a conclusion. They use the different model of calculation OE. So in this case, we try to eliminate this problem. Because every single production can be different. We together with customer create the state, the master data, and in master data we have a state of machine. We create the state, and the state is connected to the machine. Then, like I said, we create the mask for the operator, and they can choose only the existing state on their machine. We can decide together with, customer decide, is the state have, we create the OE category, and customer decide is the state have impact on OE or no. Here we have a RODQ's analysis. We can analyze very deeply what's happening on our line. We can do it. We can check the trends, for example. We can check the trends in long-term time if it's necessary. Then we can, if we make an analysis of the trend, then we can make some changes or change some steps on our production, and we can check is it has or hasn't impact on our OE. This is the example of the trend. Finally, if we create the state and put every important information to master data, we can create the OE loss tree. This is, of course, we have a lot of performance dashboard and panels, but OE loss tree is, in our opinion, one of the most important, because here we have a clear information when where we lost our efficiency, our performance on our production. In this case, if we create more states on the machine, if we create more OE category, then we have more information and bigger data to analyze how to solve and how to increase our OE and our performance on the production. Okay. Of course, we can create the reports in our system, but if the customer can do it in different way, like for example in Power BI, then we are open on that solution. Of course, we have ready interface. We call them data warehouse lake, and we can send the package of information to Power BI, because, for example, in our system, the local production manager can create the reports, but globally for all factories, all facilities in all of the world, the headquarter will be do it in Power BI. So in this case, we can send the data to the system, and customer will do it like always. Of course, our system is ready or on AI, because it's a very hot topic right now. Okay. After that, after implementation of system, what we have, what outcomes and benefits we have. Of course, the machine connectivity is better because we have measuring in real time and collecting data in real time. Microstops monitoring is responsible for finding the bottlenecks on our line, and the bottlenecks is easy to detection for our customer. We reduce the waste material. We reduce the raw material consumption because the system can give the operator and not only shorter reaction time. We have what is very important, because this is the big problem. We have all data in one place. I think it's good moment to tell you OE and microstops monitoring is a part of our system. Very often we start with single module for our customer, and then we develop the system and add some functionalities like energy management system, for example, or CMMS system dedicated for maintenance department. So in this case, we are a partner which can give you more or less every system connected with the production, quality system, paperless, and few others. And the KPIs overview. The customer have a big performance and a lot of dashboards inside our system, visualization on real-time data, and decision process is better, it's shorter, and they can create the new rules, the new steps, or reduce the steps. What number give us the implementation of OE system? We have OE increase between 12 to 17%, microstop reduction between 14 to 20% on the production, material waste reduction around 8%, and reduction of changeover time between 10 to 25% of the time before implementation the system. From my side, about the digital tool, it's everything. I think it's a good moment on the question. If you have any question, just let me know.
Yes, thank you, Sebastian. First of all, let's see if we have some questions. I will check. Yeah, we have one or two. First one would be, can the OEE system connect to any ERP system?
Yeah, of course. It's not a problem to connect with any external system. Of course, we have on the market some big players, but our customer have really different ERP system, and not only, of course, ERP system. So in this case, we are ready and we have experience with creating interface to every, I can say every ERP system on the market.
Mm-hmm. All right. The second question would be, is it necessary to connect all production machines to the system, or can we do it step by step?
Yeah, it's a very good question, because it's a very topic to discussion with our customer. We recommend to our customer to implement the system step by step. So in this case, it's a good opportunity to connect, I don't know, one line, one building, one factory. Yes, no problem. But if we do it step by step, then it's easier for customer, because we know very well the system, but like always changing the system inside the facility, inside the factory is something, it's a big event. So in this case, we recommend to do it step by step, and then it's much easier for the customer. And in the future, he can connect the single machine, single line on new facility. It's not a problem for us.